Hello students, this video is to help you with the Unit 1 project on constructions. I'm going to give a quick overview of the project and talk about some skills and strategies that you'll need in order to complete it. You should have gotten this project sheet in class. Taking a look at the directions here, you should note that it's asking you to do constructions. If I catch you doing just drawings or trying to fake any of these constructions, I'll have to take points off for that, obviously. You should make sure you're showing all construction marks. You should make sure that you identify the title, the name, all the good stuff. This is just pretty standard information, and at the end of the video I'll show you a sample of what it might look like. Keep in mind that for each construction, or for these three constructions I should say, there are questions, at least one question for each of these constructions. It asks you to type or write each question at the top of a separate sheet of paper. So you're going to be writing what is true about the location of the intersection of the three angled bisectors. You're going to be writing these questions down first, and then writing down the answers below them in complete sentences. You also need to draw the constructions with the answers to those questions. Believe it or not, this project is fairly straightforward as long as you're making sure that you're reading every single word. It asks you first to draw a large triangle with three acute angles. You know, acute means that the angles are less than 90 degrees. You also know that it asks you to construct the angle bisectors of all three angles, and you know how to do those angle bisector constructions. Those were included in Unit 1, Lesson 6. If you're having trouble remembering how to construct angle bisectors, there's a fairly helpful website called WikiHow that could help you figure that out. I've taken some of the pictures from WikiHow to demonstrate the construction of an angle bisector. The first step here is to draw this arc, sometimes called the reference arc. It's just an arc that originates from the vertex. Once you draw that arc, you're going to draw two other arcs into the interior of the angle. The first arc, see how the compass's point is coming from this intersection point? The first arc is here, and then the second arc, the compass's point should be at this second intersection point. There's the second arc. Notice that it intersects only in one place, and that place is directly in the middle of the angle. So if you draw a line from here, the vertex, to here, the intersection point of the arcs, you should get an angle bisector. So that should be pretty straightforward. You should do that 3 times for that first triangle. Notice that the next thing it asks you to do is repeat for another triangle that has an obtuse angle. This triangle with an obtuse angle, remember obtuse means it's going to be an angle that's greater than 90 degrees but less than 180. So here's an example of an obtuse angle. And a triangle with an obtuse angle would just look like that, something like that. Make sure that it says repeat, so make sure that you're constructing angle bisectors for that as well. Then it asks you the 2 questions. I'm not going to give you a whole lot of insight into these questions, but please make sure that it's talking about the intersection of the 3 angle bisectors. Let's go ahead and make sure that those angle bisectors actually intersect each other. So you're not just going to make a little tiny angle bisector here that only goes part of the way through the triangle. You're going to go ahead and extend it all the way through. And then when you draw the other 2 angle bisectors, eventually they should intersect somewhere. That's a hint. I guess I'm giving you a little bit more insight than I thought I would be doing. And then can you make a hypothesis about the 3 angle bisectors of any triangle, including the 2 triangles that you've made, and it should probably be in common with those 2 triangles. Construction number 2 asks you to draw a segment, AB, and remember a line segment is just a straight set of points with 2 defined endpoints. We'll call that AB. It says then to construct a triangle whose sides are all congruent to AB. Now let me give you a hint. When you're constructing a triangle whose sides are all congruent to AB, it's very similar to one of the constructions that we did, which was called copying a line segment. If you don't remember how to construct a line segment that is congruent to a pre-existing line segment, I have another example here for you. If you consider this line segment PQ and you're trying to copy it, you would take your compass and put the point here at P, and then I know that this picture of a compass is a little lame, but bear with me here. You would extend the compass so that it gets to point Q. So now that you've set the compass to this distance, you would make an arc here at Q. And then you would take that same distance and say, okay, well, I'm going to start at this point R, whatever that point happens to be, and then draw another arc. You can see the arc that's already been drawn here. And anywhere along that arc, you could put a point, which is now the same distance away from R as Q is from P. So again, we take a pre-existing line segment, and we put a little compass on it, and we measure it out like this with the compass, and then we go to another point R and make an arc, and then anywhere on that arc we can call it point S, and now we know that PQ is congruent to RS. As you can imagine, this compass setting is the same distance between R and S as the same as between P and Q. You can also use this to make the other parts of the triangle. If you rotate the compass a little bit and make an arc up here, and then if you rotate the compass and make an arc from point S, you could probably imagine that these two arcs that you just made exist up here, and they're going to be intersecting together to form sort of an X, sort of like this. That's a bad representation, but you get it. And now this point is going to be equidistant from R and from S because it's the same copied distance from PQ. So that's a quick example of how to get that equilateral triangle. Whose sides are all congruent. Of course, we talked about equilateral in class. Then it says copy an angle of the triangle as a separate diagram. That's another construction that we did in class. We did copies of angles, and I also have pictures to show you about that. You should recall that copying an angle requires a couple of steps. My first step here is taking the angle that's given to me and drawing a ray. In this case, they drew a line segment. I'm sorry, a line, but they didn't really need to draw a whole line. They just needed to draw this ray part. Then what they did was they drew a reference arc, similar to the reference arc that they drew for the bisecting of an angle. And they copied that arc, that same exact arc, to the line. So in other words, they took an arc and they put it here, and they took the same arc and they put it here. That's this arc number 2 and number 3. The second to last step is they took the width. Remember we called it the width in class? The width of this angle. They put the point of the compass here and the pencil of the compass here to try to get that width. And then they copied the width over to this line that they drew. Once they have that intersecting point, notice that that intersecting point is the same width or the same distance away from the intersection point as in the original angle. So if you were to just connect this like this, we have two exactly equal or congruent angles. So that's copying an angle. It asks you then to, where were we here? And that asks you then to answer these questions. Taking a look at construction 3, it asks you first to draw a circle. Many students in class asked how to do that. You have a tool whose job it is to draw circles. It is called a compass. Locate 3 points A, B, and C on the circle. Any 3 points will do. Construct the segment bisector of each line segment. Now, I know that I gave this to you, this picture to you as a suggestion, and I intentionally did not explain exactly how it works. I'm going to try to explain a little bit about it now. We're going to take our compass, the same one that we had before. I pasted that up here. And what we're going to do is sort of reverse engineer this and figure out where it came from. Well, if you have a line segment, which is AB, and you're trying to find M, the midpoint, the first thing you're going to do is take your compass and set it to a distance that's at least halfway between A and B. So that's what I'm doing. I'm setting the distance from A to somewhere past M, somewhere bigger than halfway. And then I'm going to make an arc by simply using the compass for what it does. It makes an arc here. And then I'm going to do the same thing from B. I'm going to make another arc. Notice that these two arcs are only going to intersect in 2 different places. Once we find those 2 different places, those 2 different intersection points, we draw a straight line through line segment AB. And guess what? It touches line segment AB at the midpoint. It is a bisector to that midpoint. And actually later on we'll figure out that it is not just a bisector, it's also a perpendicular bisector, but that's not important right now. What's important is that that's how you find the midpoint. So you construct the segment bisector of each line segment. So your circle is going to be circular, and then it's going to have 3 different points on it. So it's going to look a little bit like this. I have a tool that allows me to draw circles here on my drawing program, and I know that I need to make 3 different points on it. So we'll call this point A, this point B down here. They can just be wherever you'd like. And this point over here, let's call this C. And then, of course, when you're asked to draw line segments between them, you're going to use your straight edge to construct those 3 line segments. So it's going to look something like this. You have a triangle that's drawn inside the circle. Later on, we're going to learn that this is called inscribed, but that's not important right now. Then you're going to do that construction to find the midpoint. So we're going to find the midpoints of each of these line segments. We're going to find one here. By doing that construction, we're going to find one here. By doing that construction, and one here by doing that construction. And again, your circle is going to look a lot different than this because you're going to have all the construction marks. You'll have like the arc that's up here, the arc that's down here. You'll have the straight line that comes through. This is a poor artist's rendition, but luckily for you, you have a compass. So after all that is done, if you take a look at the rest of it, it asks you just to construct the segment bisectors. In other words, just to construct those midpoints. It asks you what do angle bisectors and segment bisectors have in common. I'm sure that that's a question that you can answer yourself. Now for construction 4, it says design a daisy wheel. Please be careful because it says construct a circle. That's pretty straightforward. Keeping the same compass setting. So in other words, once you draw the circle, don't change what the compass, the compass's length or distance. You're going to put the compass point on the circle somewhere and construct an arc that intersects the circle at 2 points. So you have your original circle. Look at that beautiful, perfect circle. Then you're going to put the compass point on the circle. Let's say we put the compass point here, and you're going to construct an arc that's the same radius as the circle. In other words, you're just going to make another circle that intersects the circle at 2 points. Look at that. Boom, boom. You're going to keep that same compass setting, put the compass point on each of those intersection points. That's what this part says here. And draw 2 new arcs. So you're going to draw 2 new, you guessed it, circles. You're going to continue to make arcs around the circle until you get a 6-petal daisy wheel. If you go back to the beginning of this video, in the intro, it has a little picture, and it looks sort of like a daisy wheel. That's what it should look like. The coloring and decorating it piece, the idea was we want to put this up in the classroom somewhere and make it look nice so that the eye is drawn to it. This is not going to be part of your grade. If you don't color it or decorate it or anything like that, you're going to be fine. The title info, your name and everything like that, the class, the period, etc., that's going to be 5%. The format of the presentation, just whether all of your stuff is organized correctly, that's going to be 10% of your grade. The answers to the questions is going to be 35%, so make sure that those are typed or written underneath the questions that you've typed or written. And then the constructions with all the construction marks and things like that, those are going to be worth 50%. It's 2 homework grades, and I haven't given that many homework, so that's going to be a pretty significant part of your grade. No late projects will be accepted. Again, this project is going to be due on Wednesday. I believe that is the 10th of October. Yep, it is the 10th of October, October 10th, 2018. All right, if you have any further questions, feel free to email me. You can try to contact me via Pupil Path, or you can just contact me via my email address. And that's it. That's what I have for you. Please make sure that you get this done by Wednesday. Good luck studying.